Hey, what's up everyone? Welcome to the second segment in the DIY robotics course with the Raspberry Pi Pico W, where we are building a remote control robot from scratch with obstacle avoidance using the Raspberry Pi Pico W and some simple and cheap hardware. In this segment, we'll be going over the hardware we are using at a high level, so we'll be discussing each component and briefly and what it does, and then we'll proceed with building the robot. So we'll start by building the chassis of the robot and then connecting all of the hardware and the electrical components, giving us the foundation to start writing some real programs to bring this thing to life. Now, a list of hardware for this project can be found at ShillehTek.com on the blog for this tutorial series, so be sure to go ahead and visit that if you have not already for some more detail and links to help you find all of the components you need to build this robot. As always, do not forget to like, comment, and subscribe to the channel. A bunch of new tutorial series coming out in the remainder of the year, so don't miss out. Go ahead and hit that subscribe button, and let's get started by talking about the components we'll be using today to build this robot. Okay, so let's get started discussing the components right away. So first things first, Raspberry Pi Pico W, as we went over in the previous segments. So this will just be the brain of the whole operation, where we'll be writing the code, and of course pre-soldered, as I mentioned, so these pins are attached. Very important because we're connecting components to that. You can buy these pre-soldered, as I mentioned. I just recommend buying it pre-soldered so you don't have to solder everything. It could be a pain in the neck. After the Raspberry Pi Pico W, you will need a breadboard. So breadboards are pretty common. This is a 400-point breadboard. Just makes it easy to connect components and organize them. So breadboard, and on top of that, we will need a breadboard power supply. So this breadboard power supply is also important because we'll be plugging a battery into this power supply, and this will be going into the breadboard, and that will be powering the Raspberry Pi remotely. So this is a key component in powering the Raspberry Pi remotely, is that MB102 breadboard power supply. On top of the power supply, you will need a form of power. So we're just using this rechargeable battery, and one end, so I just bought these connectors. One end is a standard USB, and the other end is a DC in. And this end will go into the MB102, and this end will go into the battery, as you see here. So pretty straightforward. That'll allow us to recharge and power our robot remotely. On top of that, we will also have this battery pack. So this is an 8-piece battery pack. So of course the battery pack comes by itself, and then you have to buy AA batteries. So I'm just using the Amazon ones. You can buy rechargeable AA batteries. If you're going to use this robot a lot, I recommend just having rechargeable batteries. And this is a separate power supply that will be powering the motors, because they will need a higher voltage than the Raspberry Pi. So we're going to use a separate power supply, and that is this 8-piece battery pack holder with 8 AA batteries. And of course, it has a connector on top here with some leads. So these are fray leads that will connect to the motor driver, which we will talk about right now. So that is very important, and that will give us enough power to move this robot quickly. Otherwise, if you have less batteries than that, you'll notice that the robot will be very weak and slow, and I've experienced that myself. Okay, so that component will tie directly into this component. So this is an L298N motor driver, and this will be attached to the battery pack, and the two ends will be attached to the DC motors, which will control the wheels. So what's nice about these devices is that they can control two wheels at the same time, and they can control the direction and the speed of the wheels. So that'll be very important for our final program and our example program with the L298N. So just some other components here. So another thing we have, I'm going to show you, is we have something very popular, and that is just a jumper wire. So I just have a bunch of jumper wires here. Ignore this one for now. This is a different type of jumper wire. We'll talk about that in a second. But just make sure you have a standard pack of jumper wires. Now mine are all fray here. Of course, when you buy them, they look all organized, but I already pulled mine apart. Just make sure you have a set of female to female, male to male, and male to female jumper wires. Probably one of the most common components when you are working in this space is just to have jumper wire. So get a jumper wire set. And on top of the jumper wire set, we also have another type of jumper wire, which is less common, and these are called alligator jumper wires. So one end of these clip is alligator clip. So look, you can just clip onto a fray lead. So the fray lead of the battery pack, this is going to be very useful, and for the DC motors as well. And then the other end is breadboard or jumper wire standard. So that makes it really easy to connect components with fray leads. And I found these incredibly easy to use and just make your life a lot easier when you're doing some quick prototyping. So go ahead and get yourself a set of alligator jumper wires. On top of that, we're going to need a chassis. So I just bought a 2-wheel chassis off of Amazon. So you see this is the 2-wheel chassis. I just opened the box. I already assembled it. I'll show you how to assemble this one specifically in the next portion of this video. But you see that this is a complete chassis. It comes with, this is going to be holding all of the electronics. It comes with the wheels, which I attach, and it comes with 2 DC motors on the bottom there. Everything I attached already, and this is a relatively cheap one, but it does the job. So if you have a better one that you like, or you already have some 2-wheel chassis with DC motors, just make sure you have a chassis that will be used for the foundation of the robot and will have wheels and DC motors. Next, we have this HC SR04 module with RGB LEDs. So you may have heard of HC SR04. It's an ultrasonic module that can measure distance. We'll be using this for some simple obstacle avoidance, that is to stop the robot before it hits a wall or that sort of thing. But what's nice about this module specifically is that it has an RGB input. So what you could do is you can also measure distance. At the same time, you can show some nice LEDs. So it just makes the robot more interesting and more fun to work with. So I'll be showing you that in a later segment in this tutorial series. So just make sure you have an HC SR04 with RGB. I'll link that down in the description below. And finally, in terms of just hardware components, we're done. Now we're just going to talk about things to help us with this project. So I have some pliers here. So this will help us assemble the robot. So make sure you have a set of pliers. We have screwdriver. So we'll be using a screwdriver a bit in this project. So just make sure you have a screwdriver set. Some scissors. So scissors will be useful, to cut the tape. So we'll be using some tape as well. So make sure you have a set of tape. I already have one here. So this tape will just help us hold things down, put things out of the way, and just hold things in their spots. So tape is important as well. Some Velcro, so you could use Velcro as well to hold things onto the chassis. Velcro has been incredibly helpful for this project. It's really strong though, and it's kind of hard to remove off the chassis, so sometimes I just use tape, but Velcro is very good. And then we have some, I believe these are called zip ties, and these can help you hold things down as well. So I just get a set of zip ties. You may have some laying around. And yeah, one thing I forgot to mention is that the Raspberry Pi Pico W does need a cable, so make sure it has a cable, of course, to connect to your computer for programming. And that's pretty much it. So we just discussed all of the components. Now that we have all of our components in order, we understand what they're doing at a high level, let's jump into actually building the chassis and then putting everything on top and wiring everything. Okay, so let's get started with building the chassis. So you could see it comes with wheels, DC motors, connectors, and other components you need. It does have a little battery holder, but we're not going to use those because that battery holder is too weak for the motor driver, so we're not going to use it. And so I just took everything out. The first thing here is the base frame. So you see the base frame comes with this paper layer. Sometimes it doesn't. I bought 2 of these and one of them didn't have this paper layer on top. You can go ahead and try your best to remove it. It will take a while. It's a bit stubborn. Maybe you can use some alcohol to remove it. It's not the most aesthetically pleasing layer. I don't know why they did this. And then the next thing, which is the most tricky thing, is you want to start putting or mounting the DC motors. So you see, to do that, you have to pretty much put this pike through, and then you want to hold the DC motor in place, and then you want to place another pike on the other side. And while you are holding them in place, you want to put screws. So it comes with screws that you're going to push through. So 2 screws, and then eventually with those screws that will secure it enough to enable you to put some washers in that comes with the assembly kit. So you want to go ahead and tighten those washers as much as you can with your hands. This is the trickiest part. So take your time here and be patient because the alignment of these motors is important. Try to get them as straight and secure as possible. So you see I am trying to tighten those washers as much as I can with my hand first. And eventually you can use tools, which is what I eventually do. I use those pliers, so that helps to tighten them initially. So that is pretty useful. With some nice pliers, you can get some more tightening there, as you see. And even better technique is once you have that, you can use the pliers in conjunction with a screwdriver. So the plier holds the washer in place, and then the screwdriver screws, and eventually you get a secure DC motor. And do the same for the other side. So once again, that is the longest component of this build. So take your time doing that. Looks good here. And once we have that, we could just do the front wheel. Front wheel is much easier. So you have these screws that go on the top, and then they hold another component, which is sort of this long hexagonal thing that goes into the screw just to keep the wheel offset to match the other wheel. So we have this front wheel, this plastic wheel, and you're just going to screw it in. And there's 4 screws, top and bottom. So just take a moment to screw that in. This one is much easier than the DC motors, and we are just going to do that. And once the front wheel is done, you can just go ahead and take the rubber side wheels and just push them in place with the correct orientation. So one on each side, and these will be controlled by the DC motors. And once you have that, your base for the robot is done. So now we could start putting things or mounting things on top of the robot. Okay, so now that we have the chassis ready, we can start putting things on top of the chassis. So first things first, I just put some Velcro on the chassis. I went ahead and removed that paper. You see, it's a little messy because I had some tape on there and I was doing some experimenting off camera. But I just went ahead and attached one side of Velcro. So first thing I would like to do is I would like to put the battery, and I prefer to put the battery somewhere in the center. And I put Velcro on the bottom of the battery. So this is the opposite of the soft Velcro. This is the other side, so it can stick. And then I am just going to place the battery somewhat here. And the reason we do that is because we want the center of gravity of the robot to be in the center of this area, just so it could be stable. So if I put the battery here and I put the other rechargeable battery in the back, I think that is a good idea. So honestly, really, you can go ahead and arrange these components as you like. I'm just showing you how I arrange them. So battery there, and you see I already put the batteries in. And then I'm just going to take the motor driver. I put Velcro on the bottom there as well. I'm just going to place the motor driver here. Okay. And then once we have the motor driver and the battery, I'm going to take the rechargeable battery pack. So now I have another rechargeable battery pack. This one's a little stronger. It has more battery life. And I just put Velcro on the bottom. So just Velcro everywhere. And then I have my breadboard on top. So what's nice about breadboards is, if you don't know, is they have a little peel there that you can peel off and actually become sticky. So for the breadboard, you don't even need Velcro at all. So I just took that peel off from the bottom of the Velcro, stuck it on the battery pack. I placed my Raspberry Pi in the breadboard, and I inserted my MB102 into the breadboard as well. So go ahead and do that. And then we can just go ahead and place this in the back. So those are the main components on the top there, and it looks like everything is balanced. So what's nice is that this battery is in the front, so it keeps the robots balanced with the heavy battery, the rechargeable battery in the back. And finally, we have the HC SR04 with RGB. So we're not going to tape this down yet, but I'm just going to put it somewhat over here, and we'll just tape that down later. So I think this is going to be the place where I'm going to put the HC SR04, and this will be front facing, so it can detect obstacles and sort of be the eyes of the robot, and it'll show some nice colors later on when we go and program it. So you can just leave it there for now, and let's discuss the actual electrical connections we need to get these components to work. Okay, so now let's go ahead and take our jumper wires and our alligator jumper wires as well, and we want to start making connections. First, let's start with the L298N to the respective components, to the Raspberry Pi and the MB102. And let's go ahead first with the 6 jumper wires on the bottom here. So we want to take 6 jumper wires. And what you'll notice with these L298N motor drivers is that they have some caps here on these pins. So these ENA, ENB pins have these little plastic caps. You can go ahead and remove those. We don't want those because we want to enable pulse width modulation to control the speed of the motor. And then once those are removed, we just want to use the 6 bottom on the L298N and just make the connections accordingly. So 3 for each DC motor, as the first 3 on the bottom here for the first DC motor, and the second on the top here for the other DC motor, and that will enable us to control the speed and direction of the motors through the signals from the Raspberry Pi, which is cool. You do not need these on the top, these 2 pins, so you can go ahead and ignore those. And of course, if you're still confused about these connections, I hope they make sense because they're color-coded. If you're still confused, more details on the blog at ShillehTek.com that explain these connections in detail and the names of the pins and everything. So if you're confused from this diagram, you can go ahead and read that. And the reason I'm not showing you physically from the beginning is because there's so many wires and it'll just overwhelm you. So I hope this diagram is clear enough to help you make those 6 connections on the bottom. Next connections we need 2 direct connections to each DC motor from these screw terminals. So if you look at the L298N, on each side it has these screw terminals. We can go ahead and just unscrew the top of the terminal. So these things are incredibly tricky. If it's your first time using them, you have to put a lot of force to essentially unscrew the terminal on the top. So you could just take a screwdriver and you can just insert it into the terminal, and then you could just go ahead and just move it to the left counterclockwise, and that should unscrew it, and it will take a lot of force. Some of these are very stubborn, so be patient and try different screwdriver heads to unscrew it. And once it's unscrewed, you can go ahead and insert a jumper wire into there and use an alligator jumper wire, actually in this case, where the other end is an alligator clip, and just clip the other end to the DC motor. This is where the alligator clips are incredibly useful because these fray leads on the DC motor are really small, and some people prefer to solder them. I just thought it was easier here in this tutorial because it's a beginner friendly tutorial where you could just clip on that alligator jumper wire on this side, and then the other side you could just insert into the screw terminal, and once it's inserted you can go ahead and tighten the screw terminal and it should be good to go. And same for the other DC motor. So that will send a signal to the DC motor to actually make it move the wheel, which is what we need for this robot. And finally, the last two connections we need on the L29AN are this 12 volts and ground. So the 12 volt will go to the red line on the battery. So imagine this is your 8-pack battery and it has a red lead. So that red lead will go to the 12 volts. In the leads on the battery, you can use another alligator clip to clip onto the lead, and then the other end you can insert it into the screw terminal, so 12 volts. And then the black lead is ground, so you can insert it into ground, and that will power the whole L29AN to supply it with 12 volts. You see there is a 5 volt option here. We do not want that. 5 volts is not enough to move this robot. I tried it myself. It does move a little bit, but it'll be incredibly slow. It pretty much is unreliable to use this thing at 5 volts, especially with the heavy weights we have by making this remote with all of the rechargeable battery packs and the battery pack. Okay, so now that we have all those connections for the L29AN, the last thing we need here is we need this MB102. So this MB102 will be plugged in to the rechargeable battery. So this is the DC in. So we can take that cable, insert it into the DC in, and insert the other end into the rechargeable battery pack, which is on the bottom. And then we just want to take 2 pins on the power rails of the Raspberry Pi. So we want to take the ground pin on one side from the MB102, insert it into pin 38 on the Raspberry Pi Pico W. So this is just the ground pin. And then we just want to take the power pin and insert it on pin 39. And we want to set the voltage of the MB102 to 3.3 volts, or I believe you could do 5 volts, but you see that they have these pins on the top here. So it's another one of those two-headed pins. I don't even know what you call those pieces, but it essentially allows you to configure the setting to 3.3 volts or 5 volts. 3.3 volts is fine in this case. The Raspberry Pi takes 3.3 volts in, and you can go ahead and set it to that. And the other side you do not have to use. You can just set it to off. And then there's a button on the MB102 you can actually turn on. So there's a button you can just click, and that turns on the MB102. We'll be using that later on when we go ahead and power the Raspberry Pi remotely. So those are all the connections you need. Next, let's discuss the connections we need for the HC SR04 ultrasonic module on top of this. Okay, so now that we have the motor driver connected, let's just go ahead and take our HC SR04 with RGB. Now we are going to use I'm going to use jumper wires, but one thing with this module is ideally you can use a 5-pin JST connector to connect directly to the module because it's more secure. So I'll link that module, that connector module, in the description down below. So if you want to make a more secure, easy connection, you can do that. Otherwise, you could just use 5 jumper wires, hold them in place, and I just use tape to hold them in place. They'll be a little loose, but it's fine. You should be able to get them to work. So yes, so the connections we're going to make are 5 here. As you see on this diagram, it's not as nice because I couldn't find this component in the fritzing program, so I just went ahead and did a quick sketch. So first, ground to ground on the Pico W. Then we have the echo and the trigger pins. So that goes to pins 19 and 20 respectively on the Pico W. We go to the 5 volt pin 36 on the Pico W, and finally RGB in, which goes to pin 34 on the Pico W. So that will allow us to control the colors of this HC SR04 in addition to measuring the distance using ultrasonic signals. Now, one thing you might be confused of is that this is 5 volts. The Pico W only outputs 3.3 volts. It's fine. I mean, from personal experience, it operates fine at 3.3 volt output from the Pico W. Ideally, you want to do something to get it to 5 volts, but that is fine for the sake of today's tutorial. We will use 3.3 volt output from the Pico W. So once you have these connections, let's go and show you how it looks in real life, so things make a lot more sense to you, because now we are done explaining all of the connections. Once again, a more detailed description of all the pins and connections we are using are in the ShillehTek blog down below. So let's show you in the next section how this looks. All right, so after explaining the connections on the screen, this is how it's going to look after you've made all of the connections. So first thing I want to show you and clarify is we talked about the MB102 briefly, but I just want to show you how that looks. So you see you have these pin connectors. So I just took one side, the side I'm taking the power from, and we are just going to switch it to 5 volts. Just do 5 volts instead of 3.3 volts. That's better for this application. So you see this thing is removable, and I just went ahead and I put it on the 5 volt section there. So that is fine, and you can see that the MB102 is connected to that rechargeable battery pack. And you can see there's a bunch of wires here, so that's why I did not show you with my hands and point to each one. It just would be impractical. We have the battery pack here, so the battery pack is connected. As you see, we talked about those alligator jumper wires. You see where they're incredibly useful because the leads of the battery are actually these fray wires, so you can just clip onto them with one side, and then the other side you could just insert to the L29AN. So it's a jumper wire, which is nice. Just makes your life a whole lot easier for this prototyping. So that's important. And the other thing I want to show you is the HC SR04, how I connected it. So I didn't have that 5-pin JST connector, as I mentioned, so I just took 5 jumper wires and I just held them together with an alligator clip and I just put them in. That's fine for my purpose. It works fine. I tested this. Really, that 5-pin JST is connected, but if you want to be provisional like me, you could do something like this. And then what I'm going to do later is I'm just going to tape it to the front of the robot. So that'll be the front facing so we can measure the distance from the front of the robot. So we'll just tape that next. And the last thing I wanted to show you on the bottom here was these DC motors, how I connected them. So you see once again how those alligator jumper clips are useful. So on those DC motors, we have the alligator jumper clips that connect to the 2 ends of the DC motors on both sides. So that side and this side, and the other ends just go to the L29AN. And what I use to hold things in place, I use some tape. It doesn't look the best, but it does the job. Just make sure you try to make those wires from crossing paths or the metal leads of the alligator clips from touching, because that can mess up your circuit. And there are going to be a lot of wires all over the place, so just use tape where you can to make sure that the wires don't fall under the robot, because later while the robot is moving, that can pull a wire off and just ruin the application, and you'd have to put the wire on again. So I just use tape here. It doesn't look the best, but it does get the job done. Overall, I think it looks pretty good, and I hope yours is coming together similar to this as well. And I hope those connections I explained on the screen and the fritzing program and on the diagram makes sense to you and you got it all together. So that sums it up for this segment of the DIY robot with the Raspberry Pi Pico W. We successfully wired and built all of the main components for our robot. Now meet me in the next segment where we begin to write our first serious program where we learn how to control the direction of the motors. Don't forget to like, comment, subscribe to stay tuned, and I will see you in the next video.